Hello everyone, my name is Mo and today I want to work on a data science project, let's say data analytics, and we have got a data set, and the data set is contains like some information about rental prices in Berlin, like the some information about different flats in different regions and their sizes and the price. So we are gonna import the data and work a little bit on this data set, and you can find it on my GitHub. I will put this link in the description. So this is the Berlin Flats CSV file, and you can see the other tutorial about reading data from GitHub. So I'm gonna go to rows and copy this, and we need pandas here. I'm gonna call this data frame df, so pd.read csv, and I'm gonna put address here so we can see the data frame. And as we can see, we have like an unnamed column, which is not important here. We can just simply, I would say, remove it because it's almost the same as the index. Yes, it's the same as the indexes here, so we can just drop it. We have region and different regions in Berlin, and conditions like new, used, or well kept, or renovated, number of rooms, and the amount of rent, and construction year, and the last one is the space, which means the size of the flats. So first I'm gonna just drop this the first column unnamed, so df is equal to df.drop, and the column name is unnamed 0, and I'm gonna drop it from the column, so x is equal to 1. Okay, and let's see our data frame. So this is what we have got here, and we have the shape here, but I'm gonna just do this div.shape to see like we have 6 columns and 764 rows, so it's quite a very small data frame. And with df.describe we can see some information about the data frames, like numerical columns, let's say. So as you can see, we have 6 columns, but 4 of them are numerical, contains numerical values, and 2 of them, as you can see here, like categorical values or other kinds of values. So with this we can see that for example, the minimum rent is 271 euros for this room, which has only one room, and it's quite old, and the space or the size of this room is, or flat, is 14 meters, or maybe the maximum one has like 7 different rooms. 14,000 euros is the rent, and it's quite new, and like 400 something is the size of the flat, so it's quite big. And you can gain a lot of information from this data frame that describe. But let's, for example, first see that how many regions we have in this data frame. So data frame that region, and let's first see what are the data frames, what are the regions here. So we have 1, 2, 3, 4, 5, 6, 7, and almost 10. You can simply just use this df region in unique. Just notice that we use just unique. Here is n unique, which is number of uniques. So we have 10 unique different regions in our data frame. And let's say I want to find out that how many what is the like the smallest flat in this data set. Smallest flat. So small flat, I'm gonna call it small flat, and I'm gonna go through data frame, and I will find the data frame that its space is equal to data frames space, this one also would be a space, and this minimum. And if I want to see the result, I'm gonna, it is df dot space and sorry, yes, here we found out that this room is the smallest room, the same with 14 square meter size maybe. And yeah, we can see the conditions here. If you have got any questions about this, we can just simply see that number here. It goes through the data frame and to the space column, and it finds the minimum number in our data frame, but here we don't need it right now. We just used it to find the smallest place here, so I'm gonna delete it. And let's go for the largest one, the flat, and largest flat is equal to the same method that actually we are using. So we are going to find a space that is space, and here just we need to find the maximum and largest flat. I just want to show the result. So here we have got this flat with like 5 rooms, and yeah, you can see all the information about it. And it's in Mitte, which is like a city center. This one is in Neukölln, and I like this Neukölln more than this Mitte. Now we want to find the what is an average, the most expensive region in Berlin. So average expensive region in Berlin according to the data set, and I'm gonna call it expensive region. And we can use groupby function here. It's quite handy in this case. So I'm gonna use data frame dot groupby. I'm gonna group by region by rent, and I'm looking for the average, so it's mean. So let's first see the result here. So we have got this result here, different regions with their average price or rent, and I'm gonna kind of sort it, because it's in this case, if you sort it, it's better to understand the like difference between different regions. So I'm gonna use that sort values, and I'm gonna do an ascending sort, so like this. And yeah, you can see this, that wedding is the cheapest one and Mitte is the most expensive one. And let's say we can plot this data, the average rent per region, and I'm gonna use matplotlib here. Okay, and I'm gonna plot just like a simple. I'm gonna have a simple plot, like just line chart, and I'm plotting exp region, this one we created before. So I'm plotting, sorry, we don't need quotations here, just information. So I'm gonna plot this one, and I'm gonna call we need labels maybe here. So X label is as we use region here, I would say region is our first label, or X label, and I'm gonna define Y label as rent, and let's go for plt.show. So we have got this information. Unfortunately, we have this like like very difficult to read region here, region names here. So I'm gonna just add a line here, so you can rotate it like 45 degrees. Maybe, I hope it works. Yeah, as you can see, we have got this data. Weighting is the most cheapest one, meat is the most expensive one, and now we can go for more other analytics here. Let's go to find the average rent and size of each region, and categorize them by the size of place. Okay, and I'm gonna call it, let's just call it average rent and size of each region. So here I'm gonna work on two different columns. So here I want to find out the average rent and size of each region, and here I want to just define it as average rent size. So I'm gonna use groupby again. That's groupby, and here I want to find average rent and size for each region. So region is the base here, and we will have two different columns here. So I'm gonna put it inside the list again, and yeah, so it's size, which is a space, sorry, and the other one is rent, and I'm looking for the average number, so it's mean, and I'm gonna again sort it, but this time you even can use this by here, and you can say that I want to sort it according to the rent or space, these two, one of these two. So I'm gonna sort it according to the space, and but this will be ascending again, descending, sorry, and yeah, Let's see what we have got. Okay, this is different regions, their average space and their average rent. So I can say that yeah, the Meta is again has largest like flats, and the rent is also, I would say, the highest, as you can see. But please notice that we sorted these values according to the space. So this is the largest one. It's not guaranteed that the rent would be the largest one. As you can see in the second one, Prenzlauer, the space is 95, which is the largest than this one, but the price is like lower than the third one. So we just sorted these values according to their space, and we can do some more like visualization, maybe this time with seaborn. So I'm gonna import seaborn, and let's have a like rel plot. You can find information about seaborn on their website. So I'm gonna do SNS rel plot, and our X is like, let's go for rent, and Y would be space, and I'm gonna just do this according to their region, like so it will give me the result with different colors according to their region. Okay, which is pretty useful in analytics. And here I just want to say that I'm reading the data not from the basic data frame. I'm reading it from here, this average rent and size variable. So here you can run it, I think, and let's see the result. So we have got this result, different amount of rents and different amount of spaces, and as you can see, this hue is showing up these regions with different colors. So the blue one is meter, or maybe this blue one, the lighter one, is weighting. So you can, this is the weighting, and as you can see, we have got this result. But let's do something else, maybe like work on it a little bit to make it more like usable. So I'm gonna use here size. So the size of the circles will be different according to the space or the size of the places. This could be a little bit better for understanding. You can see we have like a little bit like smaller circles here, because the size, the average size of flats are small in weighting, but the largest one in meter, as we already know, meter like has a lot of like large flats. So maybe we are also can use this SNS.set, so we can have this seaborn that's set to all the plots, and it makes this a little bit more like better in visualization. It's helpful if you want to visualize your data in a better way. And you also can use different palettes here. You know, this SNS rel plot has like different palettes that you can use. For example, I'm gonna add palette here. Like muted. There are a lot of them, so you can find information on the website about these different palettes. Maybe it's devil T, I think, palette. I cannot see a lot of differences, but it's quite better, a little bit better, and you can like search for more advanced things on the website. I will put the link on description. And we can have like some more things to search on this data frame. For example, the average number of rooms and size of each region. So we can go for average number of rooms and size of each region. So here I'm gonna call it average rooms size per region. You can write it whatever you want, just like what I like to define it. And I'm gonna again group by. This time again we are going to work on region, but we are gonna have like space, but this time with rooms, to see in different regions we can like categorize our data according to the space and rooms. And I'm gonna find the average, so it's mean, and again sort values. This time, because we haven't used rooms, I'm gonna go for rooms, and again ascending is false, so it's descending. We can write descending called true. There's no difference. So I'm gonna run this. I got an error here. Okay, I forgot to put like a dot here. And this is the result we have got. Different regions and spaces, and the average number of rooms. So it's average, not the like the summation or the all rooms that we have. Again, it is the first one, and the weighting is the last one. So it's like we would say, so far we know that Mitte is like the most expensive place in Berlin. It has like largest flats in Berlin, and it's averagely it's like it has more the flats in this region, which is Mitte, has have more rooms. So we even can like plot this one just like the other one we got. I'm gonna just copy it and just change some variables. So here we want to, for example, work for on a space, and I'm gonna change y to rooms. Please notice that this is a space and this is rooms, because the space and rooms are numerical values, but region is not numerical, so it's categorical or everything else. So you cannot like do minimum, mean, average, or summation on region, but you can categorize them according to some other numerical values. And that's why I'm using space and rooms, and I cannot use region. But again, I can use region as hue here, and I can go for like, instead of a space, I will use rooms, and I will leave everything like this. Let's see what's the problem here. Okay, the data I should change this. We are reading the information from this one, not the first one, so that's the problem here. And here we have got this result, like quite different, and with this plot you can like describe some other information about this data set. Could be also some other like information we can get from this data set. For example, we can find the price per square meter in different regions. So we can say that, for example, in meter, the average price per square meter is like higher than the Kreuzberg in Berlin. So how we can get this? Let's first define it. Price per square meter in different regions. And if you remember, we defined a data frame here. Let's just first find it. Okay, we have here this average rent size, and we have regions, space, and rent, and this is all things that we need for this part of the analytics. Let's first just run it and see. And I want to add another column here after rent, which is the result of just dividing the rent into the space. So like I'm gonna again call it, and I'm gonna name it like price per square, and this is simply the result of dividing exactly rent to that space. And I'm just dividing this column to this column, and it will divide all these like rows one by one and put results here. So I just did it, and just gonna run this. As you can see, we got a new column here in the same data frame, and this is the price to a square meter, and we even can like sort it, like sort values, and I'm gonna sort it by price per SQ, this column, and as we always go for ascending is false. And let's see the results, and this is quite helpful. And as I would say expected, meter is like the expensive one, so the price per square meter is like more than the other regions in Berlin. And maybe we can also like let's just take a look at the data frame. We just got this year construction. We haven't done anything on this, so we can work on this, and next on like conditions maybe. So what we can do about the year, so maybe we can like group it with the region, so we can, and then sort it, so we will have some information about the age of different regions, or age of different flats in Berlin in different regions. So I'm gonna call it like average oldest buildings according to their region. So this could be like, I will call oldest, and I will use again with groupby, and again, I'm working on a region. I want to categorize them because this is not numerical. I'm using it here, but like year construction is numerical, so it's years, and we can like do everything we want on it. Like I'm gonna find the average and then sort values, and ascending is like false, and as we are going to find the oldest, so it could be true. Ascending, and so we cannot find year construction, so I'm gonna just take a look at the data frame. Maybe I made a like mistake here. Yeah, it's oldest. I'm gonna run it. So we sorted the values, so the oldest places in Berlin is in Prenzlauer, and the other one Neukölln or Neukölln, and you can see the new ones are in Friedrichsfield, I don't know, in this region. So we got some new information about the like age of the buildings, and maybe we can go for the like the other column that we got here, like condition, because we worked on rooms, rent, years, space, region. Only left is the condition, and let's think about it. Maybe so we can maybe define like good condition or bad condition for the buildings. Let's first see that what we have first in our condition, and I'm gonna find the unique ones. So it's like first time use, so well kept, mint condition, no information, fully renovated, first time use after refurbishment, modernized, need of renovation. So we can say that maybe we can put like first time use, well kept, fully renovated, first time use after refurbishment, and modernized with mint condition in one group, and call it like, I don't know, in shape. And I'm just gonna copy it and remove those two that I don't need. Okay, no information, it's not nonsense here, we don't need it. And need of renovation is not in good shape, so I'm gonna remove it, and I can just make it like this, so that's good. So I defined like in shape here, and let's say I'm gonna like define function, and I'm gonna call it again like in shape flats. So let's say flat, I'm gonna or condition with this like function. I'm gonna find in shapes. So if condition is in shape, which in shape is this list, so it will simply return true, but if it's not, so else it will return false. And I just defined a function here, so let's just say that I'm gonna apply this to the whole data set, and I'm gonna add the result as like in shape column, another column in the data frame. So we have data frame here. I'm gonna add a data frame column here, sorry, which is called in shape. If the condition is in our list, it will return true. If it's not, it will return like false. So I'm gonna use like df. This is how we define a column. I'm gonna call it in shape and our data frame. Now it will need our the condition of the place, and I'm gonna apply using Lambda function, and this is equal to the function that we defined here. I'm just copying the name, but here the variable is x because x is like changing. So I'm gonna just find different hit. As you can see, we got like in shape with different variables here, and they're all true. Maybe we can go for like 10 to see if we have got anything false, or 20. I don't know. It seems most of them are like in shape or like in good conditions, so it's okay, no problem. Then we can do like a group by here, like we can call it like in shape group, and we can group by our again region. You want to find out that which region has like more in shape places, so I'm gonna use this column here. I'm copying because I want to show you that what we are looking exactly for. So I'm gonna just like, this time it's not the average, and we cannot use average here because this is not like numerical value, it's true and false. So I'm gonna use like count, so I can count number of true and falses, and then sort values again ascending, this time false. I'm gonna run it to see the result, and you can see that let's say Tiergarten, this region has more in shape buildings in it, and the Mitte and Charlottenburg, and the last one is Wedding, as I also expected this one. And yeah, that's how we can use this information. So let's say I'm looking for a flat in Berlin, but I have some limits, like I'm a student, I cannot pay more than 500 euros. Sometimes I need more space, so I need at least 25 square meters in my flat, so more than this. And I'm looking only for place in Kreuzberg and Wedding. So I'm gonna call it like my flats, and the first one is about price, so I'm gonna look for data frame. So let's just extend it a little bit with some different situation. The first like condition is like the rent. So the rent could be less than or equal to 500 euros. And also I'm looking for a place, the space is important here, so it should be like larger than 25. And I'm also looking for a place which has two different conditions. The first one is that this df data frame, it's about region, would be in let's say West Kreuzberg, or I'm gonna use df dot again region in wedding. I hope this is right. I'm gonna just run it. No errors so far. Let's see my choices. I think okay, I made a mistake here. Oh yeah, now I just forgot to put it inside the parentheses, because this is another, this is a separate condition, this is the separate condition as well, so I'm using or in between this or this. So I used and or together in this question, and I've got 6 different choices, 5 of them in wedding and 1 of them in Kreuzberg. All 5 of them have 1 rooms, and they are all less than 500 euros. I would say they're all old, and you can expect that because of the price. And space is quite good, in I would say these 2 are better. And but only I got 2 choices that are in good shape. You can use this. I would say these 2 are our better choices, so we can use this.